There are different ways to change an object's shape. Can you think of some of them? You can bend, twist, squash, and stretch. Some of these are easier to do with certain objects rather than others. For example, it's pretty easy to bend a straw. It's easy to twist a piece of rope or string. It's easy to squash some clay or dough. And it's also really easy to stretch an elastic band or some slime. To change the shape of objects, you need to apply two forces to either bend, twist, squash, or pull. The easiest way to see this is when we use a spring. But this also happens to other objects, like a piece of metal or your favorite sweets. Don't forget, you have to use at least two forces, or else the object will just move. Remember, if you're squashing something on a table, the table is exerting an upwards force on the object too. It's also the same when you're attaching the object to something like a grip and pulling. Let's look at stretching. When you change the shape of an object, like when you stretch an elastic band, you are deforming it. There are two types of deformation: elastic and plastic. If the object returns to its original shape after you stop pulling on it, then it is elastic. Do you think this object is elastic? The answer is yes. That's why we call it an elastic band. On the other hand, if it doesn't go back to its original shape, then the object is plastic. Do you think this object is plastic? If your answer is yes, you're right. Modeling clay is plastic because it doesn't go back to how it looked like before you started touching it. That's why it's the perfect material to play with when you want to form shapes. There are more objects on the screen. Which ones do you think are elastic and plastic? Time's up. Here are the answers. Did you guess right? Spring, rubber gloves, hair ties are elastic. Milk bottles, wood, buckets, and paper clips are plastic. Now, something we haven't talked about yet is that all elastic objects have a limit. So, what does this mean? Remember we said that an elastic band or a metal spring or a hair tie were elastic objects. But when we use these objects a lot and end up stretching them too much, they can change shape forever, like with an old hair tie. And when you stretch and stretch even more, they can snap and break, like with an elastic band when you pull it apart too much. So this means that there is a time when even elastic objects behave like plastic objects. And the point where it changes from elastic to plastic behavior is called the elastic limit. In the lab, we can find the elastic limit of objects like metals using something called a tensile test. We measure how much we can stretch an object before it changes shape forever or breaks. Let's use some sweets. In this tensile test that we did in the lab, we tried to see how this sweet behaves. We grip the sweet on both ends and then the machine starts pulling. We can also tell the machine how fast we want it to pull and stretch. As you can see, the machine is beginning to move. How long do you think it will take for the sweet to break? You can see on the screen on the right-hand side that there is a graph being drawn. This graph is showing stress and strain. Can you see where the sweet might break? And it broke. The graph is showing stress and strain. So what do these two words mean? Well, in simple words, stress is just how much pressure you're using to stretch the sweet. So this depends on how hard you're pulling it. And strain measures how different the shape or length is compared to how it was originally, before we did the tensile test. So this depends on how much you're stretching it, so how long it's getting. When we keep stretching and pulling the sweet, it will snap and break. This is the breaking point of the object. Now let's look at the graph a little closer. On the left we have stress, on the bottom we have strain. As we pull the object, like the sweet or an elastic band or even metal, it stretches. It stretches and stretches until we reach the elastic point. In this area of the graph, the object is elastic, meaning if we stop pulling, it will go back to its normal shape. After we pass the elastic point, the object is now in the plastic area of the graph. Meaning, even if we stop stretching the object, it still won't go back to its original shape. We have changed the object's shape forever. Now, if we keep pulling and stretching the object, what do you think will happen? It will reach the breaking point and break. Every object has a breaking point, but some objects, like steel, is more difficult to break compared to an elastic band. This graph we drew together is called the stress-strain curve. You can try testing different objects at home by just pulling them apart with your hands. You can even test it on different types of sweets and see how much you can stretch it without breaking. Here are some other ideas of things that you can try stretching. Have fun and happy stretching. Bye!